Okay, this is going to be the last video for today. This one says rewrite each of the following as a single logarithm. So I'm noticing the word single right now. Number 15 has 1, 2, 3 of the word log in it. So I have to combine that so it only has 1. All right, first thing I'm going to do, I look at each term. Terms are separated by plus and minus signs, and I'm going to look at those individually and see what I can do first. So like a 21 is in front of this one. That can become the power. So if I have log base 3 of the cube root of x to the 21st, that's just log base 3 of x to the 7th power. Does that make sense? For every 3 inside, you could take out 1. So I can take out 7 groups of x's. So it's just x to the 7th power. Take a 21 divided by 3. For the second one, no number in front to move up. So this is just plus log base 3 of 9x squared. And then the last one is just minus log base 3 of 25. So now I'm going to look at them all. They all have a log base 3. So now I just have to change plus into times and minus into divide. So I've got log base 3 of x to the 7th times 9x squared divided by 25. And that's just log base 3 of 9x to the 9th power over 25. It's now a single log. I rewrote that entire thing from 3 logs into just 1. Oops. Okay, next. Okay, now we've got, so now this has 2 logs. This one and this one. We're going to take 2 and combine them into 1. So this is log base 1/2 of the square root of x minus becomes divide, so over x cubed, which is log base 1/2 of x to the 1/2 over x cubed. Do you remember what we can do with those exponents when the bases are the same and they're over each other? We could just subtract those. So that would be 1 over, and I'm going to subtract them, and I'm going to put the fractional answer wherever the larger of the 2 is. So since 3 is bigger than 1/2, I'm going to do 3 minus 1/2, which is 6/2 minus 1/2, 5/2, and that x to the 5/2 goes in the denominator. That is in rational exponent form. If you write it in root form, it would look like this: 1/2 of 1 over the square root of x to the 5th. It looks terrible with the radical in the denominator, but I would probably just leave it looking like that with the 5/2. That way you're not looking at it like you need to simplify a radical or rationalize the denominator. You can just leave it. Okay, so let's see. These are just the properties of logs. You have log base a of 1, the answer is 0. That's just showing you that like a to the 0 power always equals a 1. Log base a of a is always going to be a 1. That would be like if you have log base 5 of 5. We know that that's 5 to the 1st and 5 to the 1st, so that would just be 1 over 1. Log base a of a to the x is just x. Again, that's like log base 9 and then 9 cubed. It's going to be like 3 divided by 1, which is just 3. So it's like your x. There's another property that says if you take a number and raise it to a power that has a log in it, and the base matches the base of the number, the answer is just going to be whatever's after the base. So that's just an x. So if you had like 7 raised to the log base 7 of 5, your answer just ends up being like a 5 if these two numbers here match. And then log equality says if you have log base a of x and log base a of y and they're equal, that means the x and the y have to be the same. Same properties hold true for natural logs as do logs. Remember, ln is simply log with a base of an e. So all of these hold true for natural logs as well. And then I like to remember things like line right here. The second one, line, is equal to 1. I see that word. It looks like a line. The number 1 looks like a line, so I remember that. And then this one where it's like ln of 1 is 0. I just think of that as like the word lin-lo. And I just remember ln, lo. And it looks like ln, lo, lin-lo. I remember that one too. All right, so for 17, okay, these are all just evaluate. When you guys see evaluate in the directions, you're looking for a numerical answer. So for 17, we have, get a different color, okay. We have ln of e, and I know ln of e, that's going to be a 1, but right now it's got a 7 there. So when we have a power on any type of log, you're going to take that power and bump it up to the front. Make a power or an exponent become a coefficient. And then we have ln of e. So this just gets moved to the front times ln of e. What's the ln of e? 1. So 7 times 1 is 7. Don't make the mistake of calling ln of e a 1 and making that 1 to the 7th power. It doesn't work that way. You have to move that power out in front first. All right, number 18 is ln of, and then this right here is e to the 1/7 power. Again, bump that up front. 1/7 ln of e. What's ln of e? That's just a 1. Put a 1 there. So that's just 1/7. Here we have 7 with a log base 7 of, this is just going to be 3, and that's from this property right up here. 10 of log base 10 of 14. There's no 10 there, but I know it goes there if you don't see one. So my answer is just 14. This is e to the log base e of 5. Remember, ln is the same thing as log base e. When these two match, the answer is just the other number, which is 5. This is e to the log base e of 0.2. What's my answer? 0.2. Log base 13 of 13 to the 5th. This is 5/1, or 5. And then 24 is like log base 10 of 10 to the -7, which means -7. Many students think these types of problems down here at the bottom are almost too easy. So easy that they don't remember how simple they were. So try to remember those. All right, that is all for today. We're going to have a quiz. I don't know how we'll do this. I haven't figured this out yet, but we're going to have a quiz on 10.1, 10.2, and 10.3, which is everything I've made my own videos on up until this point. So this would be the end of the material for the first quiz of the chapter. And that quiz would be 10.1 to 10.3. I will put some practice up on Delta Math for you guys. If you want to try practicing expanding and condensing logs, I'll throw some of those out there so you guys can check. I don't know if we're coming back to school. I wish we would, but I don't know what's going on. So I guess we'll just stay tuned. I'll wait to hear from the administration of how we're going to handle quizzes and tests that we were supposed to have. I know some of you are probably interested in bringing up your grade, and I believe I can start giving you guys points for the work that you've been doing since we've been out. So I will look into that tomorrow. I'm actually making this video on Sunday night at 11:53 p.m. So tomorrow when I get up, I will look at how I can give you guys some points for the work that you've done so far. So you've been doing a great job. Keep up the good work. And I hope I get to see you soon. Bye.